Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. In this problem statement, we have got a hexagonal pyramid, 25 sides of base and 50 axis length, resting on HP on one of its corners of the base such that the two base edges containing the corner on which it rests are making equal inclinations with the HP. We need to draw the projection of the pyramid when the axis of the pyramid is inclined to HP at 40 degrees and to VP at 30 degrees. So here we can understand that the type of the solid given to us is a hexagonal pyramid, and each edge of the hexagon pyramid measures 25 while the axis measures 50 Next is the resting condition. So it is resting on one of the corners, and the two edges containing this corner are making equal inclinations with the horizontal plane. So this is the resting condition, which is very clearly given. Also, with respect to the VP, it is the axis that is inclined, and also with respect to the HP, it is the axis which is inclined. So in the previous problems, we have seen the pyramid resting on one of its slant edges and the slant triangular faces, but here the axis is inclined to the horizontal plane and also to the vertical plane. Since we are going to consider the parameter which will be changing its length compared to the first position, so we have to construct the beta angle here with respect to the VP. So with this basic knowledge, let us see how the solution can be drafted for this problem statement. So let us first construct the XY line. So let us draw the XY line of any arbitrary length and annotate the line as X and Y, and also the reference planes as VP and HP. Now we'll go for the construction of the top view of the hexagonal pyramid. So let us select the line of thickness 0.50 mm. So the edge length is 25 and the angle is 0. Next, edge length 25, the angle is 60, followed by the edge length 25, angle 60 into 2, 25 and 60 into 3. Edge length is 25, angle is 60 into 4. And finally, 25 is the edge length and the angle is minus 60 or 60 into 5. So this completes the top view of the hexagonal pyramid. So we'll construct the diagonals of the pyramid now. We have completed the top view of the hexagonal pyramid. So you can see that it is resting on this corner, and these two edges containing this corner are making equal inclinations with the horizontal plane. Let us annotate the pyramid. So let us assume that it is resting on the corner A, and then annotate the other corners in the anti-clockwise direction. Also, this is the apex of the pyramid, and then we have to indicate the center of the base of the pyramid as O1. Now we shall construct the front view of the pyramid. So let us select the projection line of thickness 0.13 and draw the projections from each of the corners and intersect the XY line. So we shall first construct the axis. Select the center line of thickness 0.13. The axis length is 50 So now we shall construct the base of the pyramid. So select the continuous line of thickness 0.50. So connect the endpoints of each of the vertical projections that is intersecting the XY line, and then join it to the apex of the pyramid. to get the triangular faces in the front view. So this completes the front view of the pyramid. Let us annotate this. So this is the apex of the pyramid, which is O dash, and here lies the center of the base of the pyramid, which is O1 dash. And here it is the corner A dash, and here B dash is visible, F dash is inside the bracket, and similarly here it is C dash which is visible, and E dash is inside the bracket, and here it is D dash. So we have completed the front view of the pyramid. So now, as per the problem statement, the axis of this pyramid is inclined to the HP at an angle of 40 degrees. So if we have to align the axis at an angle of 40 degrees with respect to the the HP, we need to incline the base of the pyramid at an angle of 90 minus 40. So for that, let us select the pyramid front view along with the axis line and the annotations. And then let us move a copy of this towards the right hand side of the XY line. Now select the rotate option and incline the base of the pyramid at an angle of 90 minus 40 with respect to the HP. So this completes the front view of the pyramid when its axis is inclined at an angle of 40 degrees. So we can just extend this axis line to intersect the XY line and then measure the inclination, and that will be equal to 40 degrees. Use the extend to next option and then extend this axis line. Measure the inclination of the axis line with respect to the horizontal plane. So you can just see that it is 40 degrees as per the required statement. So next, let us complete the top view by drawing the projection lines. So from the apex, drop a perpendicular downwards, and then the perpendicular lines from each of the corners. Also from the axis. Of thickness 0.50 mm. So let us begin with the corner on which it is resting. So it is resting on the corner A. And then from corner A, let us draw this to meet the corner B. And then from corner B, corner C. So corner D is this point of intersection. And then corner E, corner F, then corner A. So from these corners, let us draw the slant edges. So the inner edges will be the dotted lines. So select the hidden lines. So this completes the top view of the hexagonal pyramid resting on HP with its axis inclined at an angle of 40 degrees. So now let us annotate. So this is the apex of the pyramid O, the corner A on which it is resting, followed by the other corners B, C, corner D, corner E, and corner F, and also the point O1. So we need to take the point O1 for the next position. So let us just make this a discontinuous line. So select the line option. So from D to O1, I'll make it a separate line so that I'm getting the point O1 and O separately. So now use the distance between option, measure the distance between the axis in the second position. So it is equal to 38.3 mm, while in the first position it is 50 mm. So we are going to consider this axis as the reference condition for the inclination with respect to the VP. So it becomes a beta angle problem. And then from any point on this line, construct a line of 50 mm length inclined at an angle of 30 degrees as given in the problem statement. That is the angle phi. From the end point, draw the locus line. Using the arc by center point, keeping the center of the arc at O, let us cut an arc of radii 38.3 on the locus of O1. So if we draw the line from the point of intersection of the arc and then the locus and extend this back to the point O, that will be the beta angle. So use the angle between option. So 41 degrees is the beta angle while 30 degrees is the phi that is given to us. So now let us incline the axis at an angle of 41 degrees. So it appears to be inclined to VP at an angle of 41 degrees. So select a line of thickness 0.13 mm and draw a line of any arbitrary length inclined at an angle of 41 degrees to the VP. Use the angle between, measure the angle is equal to 41. So on this 41 degree line, we have to align the axis of this pyramid. So now let us select all the edges of the hexagonal pyramid, outer and the inner edges, along with the axis line and the annotations. Select the move option, ensure the copy is on, and then keeping point O as the reference, place the point O on the 41 degree line. Now use the rotate option. The first point of rotation is O and the second point of rotation is O1. So incline this and now draw the vertical projection lines to meet the horizontal projection lines in the front plane. So we have completed the intersection points. Now let us draw the front view. So select the line of thickness 0.50 mm. So let us begin with the corner on which it is resting. So that is A, followed by corner B, corner C, corner D, corner E, corner F, and then back to the corner A. So the observer is going to look in this direction, so which indicates that the bottom face of the pyramid is completely visible. So from each of these corner points, let us try to draw the slant edges to intersect or meet at the apex. So the inner edges will be the dotted lines. So this base plate is completely solid, and obviously the edge lines which is originating from inside the base plate will be the dotted line. So let us annotate. So this is the apex O dash, This is the axis O1 dash, and then it is resting on the corner A1 dash. Sorry, it is A dash, and then followed by the next corner B dash. Next is C dash, D dash, E dash, and F dash. So anyways, the axis line will also overlap on this edge line, but still you can try drawing it. So from the point O1 to O, there will be this axis line. So the length of the axis in the final position will be from the point O1 dash to O dash. So this is the length of the axis in the final position. So we have drafted the solution for the given problem statement. Now let us indicate the direction of the projection lines and then complete the problem. So to summarize the solution, we have got a hexagonal pyramid resting on one of its corner A, and the two edges containing this corner, that is AB and AF, are making equal inclinations with respect to the horizontal plane. And then each of the edges of the pyramid is measuring 25 mm, and it has got a axis which is measuring 50 mm in length. And now this axis is inclined to the HP at an angle of 40 degrees. So we complete the front and the top views. And also the axis is also inclined to VP at an angle of 30 degrees. So here 30 degrees is the given angle phi, because the word appears to be is not given. So we need to construct the beta angle. So we are going to construct the beta angle by considering the axis length from the initial position and also the given angle phi. And then we are going to take this measurement of the axis, that is O1 to O in the second position, and then draw the line to intersect the locus of the previous axis line, and then find out the beta angle, which is equal to 41 degrees. So now it appears to be inclined to VP at an angle of 41 degrees. So we are going to align the axis on this 41-degree line, draw the projections, and then complete the front view of the hexagonal pyramid. So with this, we complete the drafting of solution for the given problem statement. Thank you all for watching.